Okay, we're in section 3.3, and this is the homework. The intensive homework is something that you do on your own outside the classroom, right? A considerable amount of time should be spent studying the material that's presented to you and reinforcing that by doing homework. Of course, I'm also going to do the homework for you, but the intent is not for me to do the homework. The intent is for you to do the homework. You may need to watch these videos. They'll be posted for every section. At least I hope they'll be posted for every section where it's me just going through the homework problems. Again, it may or may not be helpful. If you feel like you can do this without watching someone do that, that's great. If you think you need to watch someone do it before you try to do it, that's great too. You need to find out what works for you. But the intent of this is so you can be independent, that you can do these problems without having to be told what to do, that you'll know what to do if you see a question like this. All right, so I'm gonna change the share, and I'm going to try to do this by going to my whiteboard now. And again, I want to emphasize over here is you see a question, and then what you see next to the question is you see this little blue area, which basically outlines a solution problem. Someone could look at that and say, oh, gee, that's right, because the teacher did it. It's not because I did it. Our goal is that you need to do this on your own. I need to think about this. So there's two curves I've got now, and the two curves are as follows: y equals the sine of x, and y equals the cosine of x. And they want me to go between the points, and I'll write this down for you. The points they want to go between on the interval, x is on the interval between pi over 4 and pi over 2. All right, my first goal over here is just to visualize the problem. And what I mean by that, I'm kind of visualizing. I'm not saying I'm great at visualizing on paper. In my mind, I'm seeing this picture over here, and I'm going to, say, this is 0 over there, and this would be pi over here. And I want to talk about, one curve at a time. This is the first curve. That's the second curve. Let me talk about, y1 equals sine of x. Like my little table up, x and y. That's y1, by the way. And I'm going to start at pi over 4. And yeah, you should know that's 1 over root 2. And if I want the pi over 2, that would be 1. All right. So I'm going to kind of put that in sort of like, maybe like this over here for the sine curve. This is the number 1 up here. And pi over 4 is over here somewhere. There's a point over there. It's about 0.7, by the way. All right. Now let me do the other curve. I'll do that in blue, and that'll be y2. That'll be cosine of x. Again, I'm just trying to visualize. There's going to be x and y2. And I'm still going to just, start at pi over 4. And I'm going to stop at pi over 2. Well, this would be 1 over root 2. And what's this going to be? 0. So I got an idea what this one looks like. It looks like this over here. Okay. So I got an idea, and I'm not drawing like a really totally accurate picture, but that's not the point of it. The point of it is, what was their question? And their question was, I want to find the area between those two curves, between pi over 4 and pi over 2. And this is where I would recommend that you kind of shade the region in what they want. And they want, I'll just outline that for you. They want this region over here. Or I'll shade it in for you. And now I'm going to draw my little rectangle here, sort of like this over here. And I'm going to write the integral down now. And it should be a very simple integral. So what's going to be? Well, the differential is dx. And this is going to be an area. And where are we starting? We're starting at pi over 4. And we're stopping at pi over 2. All right. So I did the dx part. Now the question is, what's the height of that thing? Well, the height of it's going to be upper minus lower. And what's the upper curve? It's the sine. And what's the lower curve? It's the cosine. Now you have an answer key. So if we make a mistake, we will know we made a mistake just by looking at the answer key. Well, what's the antiderivative of sine? That would be minus cosine. Right? And what's the antiderivative of that cosine x would be? Let's see, that would be minus sine, right? I'm sorry, I made a mistake. Did I make a mistake? Cosine, derivative of cosine. Yeah, that's okay. And then let's see, derivative of sine is cosine. Yeah, I get sine now. Limit integration pi over 4 to pi over 2. Remember, to the paper and pencil test, what is the teacher looking at? Well, I'm not going to say all teachers are universal over here, but they may be looking at a picture. They may be looking at the integral. They may be looking at the antiderivative. They may look like they have the proper limits, yada, yada, yada. I'm steering towards the end of this thing though. Let's see if we can do it. So at minus pi over 2, the cosine, that's going to be, let's see, that's going to be 0, right? And that's going to be minus 1 minus, what do you get now? Oh boy, minus 1 over root 2 and minus 1 over root 2. All right, that's the arithmetic. And again, a grader would be looking at that. Next thing I'm going to be looking at is, let's see if we can do the arithmetic over here. And minus 1, this would be plus 2 over root 2. I want to clean it up a tiny little bit. This should be root 2 minus root 2. Now, clearly, I know that's a positive number. All right, I can put a box in this over here. Okay, I'm going to say a grader would be looking at this over here. And of course, the grader's looking at his grade is answer key. So let's take a look, see how we did. And I noticed I got a different answer now. And you might say, oh my God, I must have gotten that wrong. Let me go through that. All right, let me go through that with you. So, let me just put this over here. This is 2 minus root 2 over root 2. Well, I did what you did in Math 100, which is rationalize the bottom. And what do you get? 2 root 2 minus 2 over 2. And if you reduce this, you get root 2 minus 1, right? This is actually a better answer. I got to be honest with you, though. I would not discriminate. This answer up here and this answer over here, to me, are the exact same answer. What would a book have? It would have root 2 minus 1. Let's go back to our K and see how we did. We did good. All right. Let's go to the next one. And again, someone says, oh, they gave me a graph. Yeah, they gave you a graph. Let me still go through the work. On exams, we don't necessarily give you the graph, but these are two polynomials, and one is a cubic and one is a quadratic. What I'd like to do is I'd like to find out their points of intersection first. And how would I do that? I'd set them equal to one another. So I'd set x cubed minus 2x squared plus 10 equal to 3x squared plus 4x minus 10. This is points of intersection. Where did you learn to do that? In Math 119. So let's write this down. It's going to be x cubed. I'm going to use a zero product rule, minus 5x squared. And then what are you going to get? Plus 20, right? Oh, I'm sorry. Did I make a mistake? Oh, I'm sorry. Minus 4x. And that would be plus 20. Sorry about that. I got a little confused there. Oh, gee, I got 4 terms, cubic polynomial. I guess I'm going to factor by grouping. Get x squared, x minus 5, minus 4, x minus 5. And what do you get there? X minus 5, common to those two terms, x squared minus 4 equals 0. X minus 5, x plus 2, x minus 2 equals 0. And I got 3 solutions now. One of them is where x is 5. The other one was x is going to be 2, and the other one was x is minus 2. All right, we'll go to the graph later. There's 3 points I'm looking at. So let's take a look at that. And you plug it in wherever you like to get the y. I'm going to plug it into the quadratic because it's easier for me. And that would give you, let's see, 75 plus 20. I'm doing the 5 first. Let me point out what I'm doing over here. I'm plugging it in to this one over here because I find it easier than the cubic. All right. So I'm plugging in 5 because I think it's easy. That's going to be 75, 85, 95, 85. I plugged a 2 in. You can get 3 times 4 is 12, plus 8 is 20, 10. Put this over here. Going to put minus 2 in there. What do you get? 12 minus 8. 12 minus 8 is, let's see, 4. 4 minus 10 is minus 6. Now, by the way, mistakes do happen, but I want to go over to the graph and I want to see if I see these points of intersection. Do I see the point 210? It's right over here. Do I see the point minus 2, minus 6? That's right over here. All right. Now I'm going to outline the red curve to you. That's the quadratic, right? So that's this curve over here. This is the quadratic. Again, just drawing that in there best I can. And I'm going to do the blue curve now for you. I'm going to say this is the blue one. And again, I'm glad they gave me a graph because it makes it easier for me. This is the cubic over here. All right. Now someone says, where's that 0.585? It's over to the right. But what they want to do is they want the area that they're showing me over here. And let me emphasize what I mean by that. They want this area, this whole thing over here, this whole shaded region over here. They want this. Now, what am I going to do? I'm going to be drawing in a representative rectangle, something like this over here. All right. I want that. All right. Let's put my integral down, and it should be fairly easy to do. It's going to be the integration. And what's the differential? The differential, give me 1 second. I'll push this away. Let me get rid of this stuff over here. I really don't need it anymore. I'm concentrating on problem number 2. The differential is dx. Seeing it? Put this right over here. What's my limit of integration? I'm going along the x's, and I'm looking at it's -2 to 2. What's the upper curve? It's the cubic. All right, so I'll write that down. So it's going to be x cubed upper 2x squared plus 10 minus the lower curve. And what's the lower curve? It's 3x squared plus 4x minus 10. So again, if I were a grader, I certainly wouldn't look at the picture because the picture is provided to you. I couldn't grade that for you. But I'd be looking at the point of intersection. And if I were a grader, I'd say, good job, good job. Next thing I would look at, did they get the proper integral down? And I would say if they did, good job. Let's see if the next step would be, what's the next step in doing this problem over here is, probably simplifying the integrand. And what do you get there? X cubed minus, well, let's see what you get over there, minus 5x squared, right? And then what do you get? I guess you get minus 4x, and 10, minus 10 is plus 10. All right. And again, I would say they simplified the integrand. I'll just put a check in that one over there. Let's go to the next thing. And what am I going to do? Well, I guess I integrate. There's not much else I can do with that, right? So I think I can integrate. What do you get? Well, you get x4 over 4 minus 5x cubed over 3 minus, well, that would be 4x squared over 2, which is 2x squared, and then plus 10x. Limits of integration -2 to 2. And again, I'd be really happy to see a student get that far. Of course, I want to go to the end. I don't want to just simply stop. I want to get to the end. Here's the deal, though. You might make a mistake at some point. If you're going to make a mistake, please make it towards the end. All right. Let me see if I can do that. So I'm going to do upper minus lower. Yep, it's arithmetic. And what do you get there? Well, 2 to the 4th power, that's 2 times 2 is 4, 8, 16. Well, 16 divided by 4 is 4. Minus, well, that's going to be 5 times, well, 2 cubed is 8. That's going to be 40/3. Yeah, it's arithmetic. What do you get over there? 2 times 4, which is 8, plus 20. Right, we'll do that later. And I'm going to do the lower limit now. What's that going to be? Well, 4. And this is going to be plus 40/3. Don't be intimidated. And then what do you get? You get, let's see, I got -2 there. So it's going to be -8. And then you're going to get -20. All right. Remember, if you're going to make a mistake, make it at the end. Well, I'm going to say 4 minus 4 is nothing. That's pretty simple. Now, -40/3 minus 40/3 is -80/3. -8 minus a -8 is nothing. Let's keep going. 20 minus a -20 is 40. All right, I'm going to do my arithmetic now. I'm going to combine these. It's a common denominator with 3. So -80 plus 120, and that would give me 40/3. Okay. Now, granted, I don't know. Maybe I made a mistake somewhere. Maybe I misunderstood the problem. Maybe I got it wrong. Who knows? Let's go to the next page. And I'm hoping to see 40/3. And I'm not. What am I seeing? I'm seeing 160/3. I made a mistake. So the question is, where'd you make the mistake? So I got to go back and I have to look at it. And I made a mistake somewhere. And let's see where we made the mistake. And I made a mistake somewhere, and that's awful. Let's take a look where I got. And I'll take a look. X4, 2 times 2 is 4, 8, 16 fourths is 4. I got that good. And then 8 43rds. Let me look at my anti. You know what I'm going to do? I'm going to pull a key over. This could happen to you when you're doing homework. I copy it. Go back to my page now. Paste it in. Whoops, sorry about that. I'm going to push this up a little bit. This down. It's over here. Yeah, I'll pull it up here. Take a look at it. Do we get the right antiderivative? X over 4 minus 5x. I made a mistake. And let's take it. I see it right now. So I got to get my eraser out. I see it. And this is so important. When you're doing study, you go back and you look at your work. All right. So let me just move this thing down. I'm going to erase this. And I made a mistake. So I got to go back over my notes and find out where did I make the mistake? And I see it now. All right, so I'm going to tell you where I stopped and I made a mistake. And someone says, is there a penalty for making mistakes? Of course there are. So what did I say? I said 10 minus a minus 10 is 10. That's not true. What is it? It's 20. I'm going to get my eraser out. And you'd want to do this too. And what goes over here now? And I know it's frustrating. Someone says, I don't want to do that. I just want to, I'll just accept my penalties in life. And I'll deal with it later. And that's not a good policy. Oh boy, sorry about that. I'm going to try again. I'm going to try until I get it right. So what do you get over here? Well, I certainly getting better at Richard because I just tried, right? So what do you get over there? You get 2 to the 4, 16 over 4 is 4, minus 40 thirds, minus, that would be what, 8, plus, let's see, 40, minus 4, that would be what? That would be, let's see, plus 40 thirds now, minus 8, and then minus 40. I'm going to add things together. I'm getting a little better. So 4 minus 4 is nothing. Minus 40 thirds, minus 40 thirds, minus 80 thirds. We'll look at the key later. Minus 8, minus 8 is nothing. And 40 minus 40 is plus 80. Common denominator is 3. Minus 80, 3 times 80 is 240. 240, that'll be 160, right? 160 thirds. All right, I'm seeing it now. Again, the point of giving you a key is so you look at it. If a mistake occurs, you go back and correct your mistakes. It's that simple. Let's go to the next question, which is problem number 3 now. All right, now it's tough. All right, when I say things are tough, a lot of students struggle with this. All right, and really where they struggle with it, kind of struggle with basic things over here. So certainly I'm looking at that. And, certainly I give you suggestions, and my suggestions should be taken with a grain of salt. Like all suggestions, you need to start doing it your way. But the bottom line is at the end of this problem, it's going to be the same problem. Now, what I notice for a lot of students, what causes so much trouble for this problem over here is the way the problem is written. It's written as x equals sine of y, and it's written to x equals 1 minus cosine of y. And really what they're doing is they're changing the roles of the variables around. So what I'm going to do is I'm going to go back to the familiar. So I'm just going to rewrite. No, it doesn't need to be done. What's the rewrite going to be? Y equals sine of x. So what am I doing? I'm letting x be y and y equal x. Not going to change the problem much. So what do you get over here? Y equals 1 minus cosine of x. What is that dot there? Get rid of it, right? Okay, what else do I have over here? An interval. What's the interval going to be? Well, now the y is going to be x, so it's going to be 0, x, pi over 2. All right, remember this. If the letters are confusing you, you may want to change the letters that are not confusing you. So, I think you probably know what I'm going to do. I'm going to try to visualize what the problem is. And let me just see if I can do that. And I'll put my little axes down over here. And let's see, the y sine x between 0 and pi over 2. What does that look like? Like this over here. This is pi over 2. And what does 1 minus cosine x? Well, I know cosine x looks like this here. Something like that. And if I did the opposite of cosine, it would look like something like this over here. And what am I doing now? Well, I'm shifting it up 1 unit, right? So I'm shifting it up 1 unit. So I can say something like this. All right. All right. What's the upper curve? Let me write this down for you. This upper curve is y equals sine x. That's that upper curve. What's the lower curve? I'll do that in green. It's going to be y equals 1 minus cosine of x. And what am I trying to do? Well, I'm trying to get that area between them, right? Representative rectangle. I'm going to put my differential down now. Again, remember, we have an answer key, and we're going to look at it. So I'm going to say my differential is dx. I'm going to go from 0 to pi over 2. And what do you get over here? Upper curve, which is sine of x, minus the lower curve, which is 1 minus cosine of x. Again, I'll talk about grading of it later. Let me keep moving forward. It's going to be 0 pi over 2. This is sine x minus 1 plus cosine x dx equals, well, I'm going to say the antiderivative of sine would be minus cosine of x. Let's see, minus x. And then what do you get? Plus sine x. Limiting 0 to pi over 2. And let's see if we can do that. Let's see, the cosine of pi over 2 is going to be 0. That was easy. Minus pi over 2. And the sine of pi over 2 is 1. Minus, now if we do 0, that's going to be minus 1, minus 0, plus 0. That's pretty simple. Keep going through it. And what do you get over here? Well, the arithmetic really doesn't look too bad to me. It looks like 2 minus pi over 2. This can be written, common divisor 2, 4 minus pi. Okay. What I'm going to encourage you to do over here is just, I realize you might say, what is a grader looking for? They're looking for your work. What I say I did, I said I rewrote the problem. A grader would look at that and say, okay, fair enough. Then they see this over here. They see a picture. They see an integration. They see a bunch of work down over here. And they're kind of looking at it one step at a time. Do they look at the end? No. They look at the beginning and see if it goes to the end. Let's see what the work was over here, though. So over here, whoops, I think I went too far on that one. Yeah, I did. I'm sorry. I kept going. So I did it. It's right over here, right? So 2 minus pi over 2. Let me point out what I mean by that. I'm seeing that answer over there. Feel good about it, all right? Now someone says, why do I need to look at your work? Well, it's really the same work we did in the ink on the whiteboard. All right, let's go next question. By the way, pictures being provided, that's some better pictures, no doubt about it. Okay, let's just do number 4 now. And my goal over here, they didn't give me a graph. And again, I might be upset by they didn't give me a graph, but I'm going to say, well, let's take a look at this. I guess I could change X and Y again, right? I don't know. I don't think I want to do that. Let me just simply see if I can solve this thing. And what do you mean by that? Find points of intersection, right? And I'm going to write that down for you. So I'm going to be looking at these two curves, this curve here. and look at this curve over here. And I want to find out where they intersect one another. All right, so let's write this down. So that means y squared minus 5 would equal 3 minus y squared. All right, that's not so bad. I think I can handle it. So what do you get over there? You would get 2y squared. I'm adding y squared to both sides. Add 5 to get 8. Divide by 2, you get y squared is equal to 4. That means y would equal plus or minus 2. So I know I got intersecting points, and one occurs at 2, and the other occurs at minus 2. Whoops, that's not right. It's y, isn't it? Let me erase that. That's important, isn't it? So the y is 2 or minus 2. What's the x? Any equation will do. Any equation will do. Well, if you plug in 2, what do you get? You would get 4 minus 5, which is minus 1. If you do the other equation, you can get 3 minus 4, which is minus 1. Now, if you try minus 2, you still get minus 1. All right, so somebody said, what are you going to do now? Well, I would like to visualize if I can. I would like to visualize the problem. I realize a lot of students said this takes too much time for me to do, but I think I can handle it. And, minus 1, I got to go up 2, and I got to go down 2. And I'll plot those 2 points out for you. Okay. So now, again, another problem. I got to draw curves through that. And let me do one curve at a time. And the one curve I'd like to do is this blue curve over here. And it's got a vertex, right? And what's that vertex going to be? Well, that would be at minus 5, wouldn't it? Put this over here. And what does that look like? Sort of like this over here. All right, let me do the other guy. And that's the green curve. That has a vertex at 3, doesn't it? 1, 2, 3. What does that look like? This over here. Oops, sorry about that. It goes through here. And I got to get the area between those 2 curves. And what is that? That's like this business over here. All right. Now what I'm going to do is I'm going to put my representative rectangle in now. But I'm going to do it this way. And so what's the differential now? Well, the differential now is dy. And what are we starting at? Well, again, I want to point out these points are really important. I'm going to be starting at the lower limit, which is minus 2, and moving up to the upper limit, which is 2. We're moving along the y's. What's the upper curve? It's the green one. So it's going to be 3 minus y squared minus the lower one, which is y squared minus 5. All right. What's the worst problem about these problems for most students? Just setting them up. Let's keep going. Minus 2 to 2. And what do you have there? 3 minus 5 is 8. Minus 2y squared. Antiderivative, excuse me, 8y minus 2y cubed over 3. Limits integration minus 2 to 2. What do you get there? Got to evaluate it. And it's going to be 16 minus, let's see what that would give you, 16 thirds minus the lower limit, minus 16, and now it would be plus 16 thirds. Yeah, I think I did okay. 16 minus the minus 16 is 32. Minus 16 thirds minus 16 thirds is minus 32 thirds. Yeah, you need arithmetic. This would be 3, common denominator, 96 minus 32. By the way, if you can do this quickly, please do the arithmetic quickly. What's 96 minus 32? That would be 64 thirds, right? Okay, let's look at the K. And what I mean by that, a grader, again, I want to point out what a grader is looking for. Simple stuff that you might have done in 119, graphing you did in 119, setting up the integral, which you actually did in 121, but we're reinforcing in 122, simplifying the integral, getting its antiderivative, doing the arithmetic, and getting an answer to it. All right, let's take a look. Wow, 64 thirds. Now, someone says you're going to look through the work. It's really the same work we did at Chicken Scratch. I do like the tip set version better, though. All right, let's do number 5, a little more complicated. And I think you probably know what I want to do. I want to do the problem. All right, what does that mean? For me, it means visualizing. All right, let me write down this visualization for you. And I got 2 curves. And let me tell you what those 2 curves are going to be. This is going to be one curve. And this will be another curve over here. I want to find a point of intersection first. So what do I get? I got, let's see, x is equal to y cubed minus 18y. And you got y plus 2x is equal to 0. Now, again, when you took 119, you did this, you solved these equations. And the way you did that, you did it by substitution. So I'm going to take this second equation and solve for y. And what is y? Y would equal minus 2x. And then I'm going to take this thing here and I'm going to plug it in up here and see what you end up with. What do you get? X equals, well, what's this? Y is now minus 2x, right? Cubed minus 18 times minus 2x. All right, now I want to kind of guarantee that I really do believe things are going to work out really nicely for you if you try. And what do you get over there? Well, you get minus 8 x cubed plus 36 x. All right, looks pretty tough, doesn't it? It's going to be 0 minus 8x cubed plus 35x. All right, and let's keep going. All right, you'd say, keep going, you want to keep going. And let's take a look. I got 0 equals, I'm going to factor an x out, and you get 35 minus 8x squared. And I'm going to go through it. You know, when I say go through it slowly. So the solution to the problem is going to be 0. X could be 0. What else could x be? I'll write this down for you. It's 35 over 8 equals x squared. So x would equal plus or minus the root of 35 over 2 root 2 plus or minus, I'm going to multiply top and bottom by root 2. That'd be root 70 over 4. So it's going to be root 70 over 4 comma 0 and minus root 70 over 4 comma 0. So, by the way, I'm sorry, I didn't mean to do, I don't know even why I said that. That's simply not true. All right, I got to get the points. Now, someone says, where are you going to plug them in? And I want to emphasize, the place you plug them in is the easiest place you could find. So let me just do that for you. I'm going to say probably here. Whoops, sorry about that. Let me circle it for you. I think this is the easiest place. And what's y going to be? Minus 2 times that number. So let's write down one step at a time. 0 minus root 70 over 2 and root 70 over 2. All right. So then, you might say, I don't even remember what they want me to do with the problem. Well, I'll read it to you. It says, find the area of the region enclosed by the graphs. Well, there's 2 regions now, right? How do I know that? I got the cubic, and I'm going to go through graphing the cubic for you now. And let me just say what that is. X equals, and again, I need to visualize. That's y cubed minus 18y. I'm going to graph that like I did in Math 119. And it's important you get an idea that you can graph these things like you did in 119. So x would equal, well, this would be, let's see, I'd factor a y out, right? So you get y squared minus 18. And I think I'm ready to do this. Again, I'm not saying it's easy for you. So I got points of points that I like. I'm going to say the points I like in this curve over here would be where y is 0, x would be 0. That's that point over there. And another easy point for me would be plus or minus the root of 18. all right, for the y. All right, I'll put those down for you, right over here and right over here. I'm going to label those for you though. This point over here is going to be 0 minus root 18. And this point over here is 0 plus root 18. By the way, if you want to write root 18 down as, this would be 9 times 2, it should be 3 root 2. That's fine too. 3 root 2. Now, someone's going to say, I still don't know what the graph looks like. And it's a cubic problem, right? So what I want to claim is that, maybe simple sign analysis might help you with this. And I'm going to make this one in blue. I want to make that in blue. Let me do some simple sign analysis to do that though. And when I do that, again, it's something you learn in Math 119. If I took y, well, a number here, a good number over here to pick would be 1. And if you plug in 1, what you get? You get 1 minus 18. So it's negative over here. Okay. So I'm gonna draw that in. And I'll do something like this over here. Now I'm gonna go over here and I'm gonna pick minus 1 over here. If you look at it, you get minus 1. What would you get over there? Plus 18. So it's positive there. I think the idea that you get some idea about this, that if I took a number like, like 100 for the y, it would turn out to be a positive. And if you did it like a minus, it'd turn out to be negative. So I just did that graph over there. All right, not so bad. So someone says, what's the other graph? And the other graph was y equals minus 2x. I'll write that down for you. And let me I think I'm going to do that in red. And that's a line, right? And that line intersects the curve at a point. And what point does it intersect at? And this for last is really difficult, but certainly at 0, 0. Right? You knew about that. That's right over here. And what's the other one? Well, this is where some students really struggle, but I'm going to say maybe something like this over here. All right, let me draw that point in. Let me draw this point in. And I'll talk about the area that they're talking about now. I'm going to shade it in for you. This is the area right over here. This graph has tremendous symmetry. So what I'm going to do is I'm going to do the problem now. I'll write the integrations down. Oh, I forgot to put the point of intersection down. Let me do that for you. So 0, 0 I got down. This one's going to be, let's see. Whoops, I'll put this over here. That's that point there. And this point here is right there. All right, I'm going to push this out. I'm going to put my integration down. How do I do that? Well, I'm only going to do one of them. There's my representative rectangle. And when I say I do one of them, if I do the one on top, the one on the bottom is going to be done too. So I'm going to say, I'm only going to do one of them, but I'll double it. And what am I going to go through? What's the y going to go through? It goes from 0 up to, right, up to root 70 over 2. Okay. What's the upper curve? And by the way, we're only doing the one on top. There's perfect symmetry here. So what do you get? What's the upper curve there? Well, it's that curve y equals minus 2x. Let me point out that to you right over here. But before I do anything, what I want to claim over here is I've got upper minus lower, and I'm moving along the y-axis, so it's a dy. So I need to know what this is in terms of y's. And so this thing in terms of y's would be minus y over 2. Let me write that down for you. So the upper is minus y over 2. What's the lower curve? It's y cubed minus 18y. Let's go through the integrations. Again, this is a more involved problem, but let's write this down for you. It's going to be double. Let's do the antiderivative. That's going to be minus y squared. Oh, you know what? Maybe I should simplify first. And I apologize. I always say I should simplify first. I put that down for you. It is important. First of all, I got to make sure I copied it right. I'm sorry, I copied something wrong here. That's 70 over 2. Let me go back over here. It's just sloppiness. I just remembered it's sloppiness now. So what do you get over there? Well, you get minus 18y, which is plus 18y, x minus a minus, and minus y over 2. That's going to be 36, 35. And then minus y cubed. Let's keep going through it. I'll do the antiderivative now, which is going to be double the integral. Well, let's see, 35y squared over 2, oh, over 4, I'm sorry. Minus y4 over 4, limits of integration 0, root 70 over 2. And we know it's difficult. I'm not saying it's going to be easy for you. I got to simplify. I really do. So 35 y squared over 2 minus y4 over 2. Limits integration 0 to root 70 over 2. I think I can handle it. And let's write this down. So upper limit, 35 halves times root 70 squared, which is 70, over 2 squared, which is 4, minus, ooh, this one's going to be tough. That's going to be 70 squared. And then you get, let's see, 2 to the 4th power. 2 times 2 is 4, 8, 16. That's 32. Lower limit, that's nice, 0. So I'm going to do it. I'm going to see if I can do it. All right. And as I do these things, you may say, I can't get there. I need a calculator. I don't know. I don't think I need a calculator yet. I'm going to factor out a 70, though. I don't like that. And what do you get over there? 35 over 8 minus 70 over 32. All right, let's keep going. 70, 32. Let's see, 4 times 35. That's 140, right? Let's keep going. 70 times 70 over 32. I think I can do some reductions. I'm going to divide through by 2. I'm going to divide by 2 again. So what do you get? Whoops, I'll get in black. 35 squared over 8. I'm going to do the arithmetic though. And some people get very annoyed by arithmetic. And it is annoying sometimes. And I'm just going to do it. 5 times 5 is 25. 5 times 3 is 15, 17. Let's see, 3 times 5 is 15. 3 times 3 is 9, 10, 5, 12, 12, 25. All right, let's see what we got. Let's look at this. Wow, look at all that work. $12.25 over 8. Let's go back over that. Yes. Is there work involved? Yes. Is there places for partial credit? Of course there is. What's the problem for a large number of students? Just getting an indication of the visual of that. We did okay. Thank you for your attention.